Okay, sorry, can everyone hear me?
Yes.
Okay, and everyone can see the screen?
Yes.
Great.
Wait.
Sorry about that.
Okay.
My mic is not working. So, hi everyone. Thanks for being here, and thank you, Sinai, for the invite. So I'll be talking a little bit about the Ford Fellowship and a little more generally and about writing in science. So my name is Carlos Guzman. I'm a 5th year in the Bioinformatics and Systems Biology program. And the deadline for the Ford Fellowship this year is December the 17th. So just a heads up there. So I just want to talk a little bit more generally about fellowships and grants in science in general. So there's 2 major types of categories for fellowships: intramural fellowships, which are kind of fellowships or grants that are awarded by the university you attend, as well as fellowships or grants awarded by sort of private foundations or institutions. And these are your extramural fellowships. The Ford itself is an extramural fellowship. It's a fellowship that's awarded by a private foundation known as the Ford Foundation. And the mission statement for the Ford is right here in quotes, right? The Ford Foundation seeks to increase the diversity of the nation's college and university faculties by increasing their ethnic or racial diversity. And just a little bit of basic information about the Ford. It gives you a $27,000 stipend for 3 years, which you must use within a 5-year period. It also gives you an invitation to the annual conference of Ford Fellows. The last one I went to was in Puerto Rico, so it's very fun. And you get to visit some very cool places, listen to some really cool talks. You also get access to the Ford Fellows Mentors Network, which has been a really great help for finding sort of examples of fellowships for almost every other kind of fellowship that you can think of. So some of the components of the application process are pretty standard, right? A personal statement that's 2 pages long, a previous statement of research that's 3 pages long, a plan of graduate study that's 2 pages long, and then at least 3 letters of recommendation, up to 5, with 4 being highly recommended by the Ford. The eligibility is you must be a US citizen, national, or permanent resident, or be in the DACA program. You have to use up all 3 years of your support. You can't use up 1 or 2 years. You must be committed to a career in teaching and research at the college or university level. This is pretty important because I've had people ask me, what if I'm not? The answer I give is it doesn't matter. You have to pretend you are. And you also must be part of an eligible field of study. There's dozens, I'm not going to list them out, but most fields are eligible. And surprisingly, most of the recipients are in the social sciences and the humanities, not necessarily in STEM. So I just wanted to give a rubric of what is generally rated by your reviewers. So your application is reviewed by 5 different reviewers. And if you make it to the end, you get 5 reviewers. If you don't make it as far in the process, you get anywhere from 1 to 4 reviewers. So the number of people that have reviewed your application tells you how far in the process your application has gone. And they kind of judge on 5 different metrics here: academic achievement, personal statement, scholarly productivity, proposed plan, and letters of recommendation. As you can see, you don't need to have excellence in every single kind of category. Sorry, this is, turn this off real quick. You can have some pretty bad scores in some of these, right? But in general, your GPA and your background is sort of important, sort of. My GPA, so all 5 reviewers give the exact same comments for me, where that my GPA was horrendous. Your personal statement kind of talks about how your capacity to respond to different students from different diverse environments, how you yourself have engaged with groups of underrepresented minorities in academia, as well as how likely it is for you to use that diversity and that experience you have in order to teach and mentor URMs. Your scholarly productivity talks about sort of the previous research that you've done, as well as any publications and presentations that you may have done or given. Your proposed plan is kind of your research plan. So the quality of that proposed plan is important. Your application is reviewed by people hopefully in your field, but generally not, because like I mentioned, especially in STEM, the number of STEM reviewers is probably really low. There's not many STEM awardees for this fellowship for some odd reason. The evidence of applicants' ability to achieve those stated goals and the appropriate of the proposed institution, as well as sort of the relationship of the plan to your career goals as you move forward. And then your letter of recommendation are just sort of the strength and the appropriateness of choices. So, one question that I often see that isn't really asked is, what type of application does the Ford want to award, right? Because it's very different from the type of application that the NSF GRFP wants to award. And, generally applications that focus, the Ford wants to award applications that focus on overcoming adversity. This doesn't mean that the research component of the award is unimportant. It just means that your project just has to make more sense as opposed to being groundbreaking. So what does it mean to overcome adversity? And this is a really tough question, right? Adversity isn't a one size fits all kind of thing. Everyone has to overcome unique obstacles and challenges to get to where they want to be and where they are. And the question you have to ask yourself, well, what are yours? And not only that, but how have you used those challenges to grow as an individual and as an academic? And how will you take those experiences and use them to further the goals of the foundation, right? Which is to increase diversity in academia. And here, typically, I would give you're given tips about writing specific proposals or fellowships, but in all honesty, they're all pretty much the same. And the presentation you'll hear from the GRFP does it much better than I would. So instead, I kind of want to talk a little bit more about writing science in general. And I think this is a good idea because it applies to both grant writing and paper writing, right? So as a scientist, I think something that's often underappreciated is you are a professional writer. So if you want to see examples of good writing, you go to the leaders in your field, right? Most of them write exceptionally well. And the question that you can ask yourself is, well, is this an accident? And of course not, right? These men and women not only think more deeply and more creatively than most people tend to, right? But they're also able to communicate what they're thinking in ways that make it really easy for the people in general to understand. That's how they become leaders. So your initial reaction to this will be, well, you assume that these people think more clearly, more clearly than most. And because of that, they write more clearly. And certainly they do both, right? But the question is, does clear thinking lead to clear writing? And there's a really nice quote, right, from Scott Montgomery that says, I ask finally that you avoid one error of belief that is monstrously prevalent. This is that the widespread notion that to write clearly, you must first think clearly. This sharp little maxim may appear logical, but it's really rubbish. Good clear writing that teaches and informs without confusion, emerges from a process of struggle. So I think sort of what Scott believes is sort of what I also believe, that as you focus on writing more clearly, you force yourself to think more clearly. So it's not that you think more clearly, therefore you write more clearly, it's actually the opposite. Therefore, again, as a scientist, you are a professional writer. And the question is, how do we become good writers? And again, there's a really great quote from Anne Lamott, right, in Bird by Bird, that says, I wish I had a secret I could let you in, or let you on. Some formula that my father passed on to me in a whisper just before he died, or some code that enabled me to sit at my desk and land flights of creative inspiration like an air traffic controller. But I don't. All I know is that the process is pretty much the same for almost everyone I know. Praying that you do not die before you can completely rewrite or destroy what you have written, lest the waiting world learn how bad your first drafts are. And this brings up an incredibly good point. Even the most successful writers struggle with writing. And it's actually easier for us as a scientist or scientific writers, because readers, also scientists, our expectations are really low and we really want that information. And we'll fight through cluttered sentences and all these disconnected paragraphs to get to it. But the problem is, if readers have to fight that fight, some of them will lose. And then you as the author are the greater loser, right? So the single greatest overriding principle that I can teach you today, or that hopefully you take from this talk, is as the author, it is your job to make the reader's job easy. And this is actually so important that I'm going to actually repeat it. As the author, it is your job to make the reader's job easy. And this brings me to my second point, and second and last point, because I don't want to make this too long, that I want to make today. Good science writing means becoming a good storyteller. And Elizabeth Colbert, which authored a really great book on climate change that's called Field Notes from a Catastrophe, once said that the problem that she has with scientists is that we don't tell stories. But we do. It's just that the stories we tell don't follow the typical type of story that someone would read, right? But if we didn't tell stories, we would write papers with only method and results. We would completely skip the introduction and discussion portion of our papers. And the question then becomes, how do we become good writers again, right? And so a paper doesn't only present our data, it has to interpret them. A paper tells a story about nature and how that nature works, and it builds the story from the data, but the data itself is not the story. And our type of story didn't connect with Colbert. And why, right? Joshua Shamel, who is an author of this incredible book that actually this entire talk is based on, called Writing Science, suspects that there's 3 different reasons. First, scientists tell stories using a very formalized structure that doesn't match well with that used by fiction writers or other writers such as journalists. Second, many of us are really poor storytellers. You never learn how to write correctly in science, right? I've been writing fiction for 3 years now, and it's very obvious when you take a sort of English curriculum and compare it to the scientific curriculum that most universities give. We either don't see the story very clearly, or we just can't tell it very clearly. And finally, some or perhaps most scientists are uncomfortable with thinking about what we do as telling stories, right? Because many associate the idea of stories with fiction. So again, how can we tell better stories? How do we become better storytellers? So in order to tell better stories, we need to get better at finding the story within our data. And there's this really great quote again from Anne Lamott that touches this point very clearly. It's, characters should not conversely serve as pawns for some plot that you've dreamed up. I say, don't worry about the plot, worry about the characters. Let what they say or do reveal who they are and how they are, and be involved in their lives. And keep asking yourself, now what happens? And so how do we as scientists take this advice? Our characters aren't people. Instead, they can be molecules, organisms, ecosystems, or even concepts. Genes or their functions can be characters that we need to listen to by carefully analyzing data with an open mind. You then develop the story by developing these characters in the paper that as you talk about them and you try to figure out what makes them tick. And the challenge lies within that distinction between just presenting results and telling a story. If you believe that writing a paper should be about presenting results, then it's reasonable to just sort of outline everything you did and then say something about it. But somewhere in that mass of data is a story that you're trying to come out. And the role of scientists should be to collect that data and transform it into understanding. And understanding is really telling a story. Question is how? And again, a great quote from Joshua Shamel. Going from data to understanding is a multi-step process. The raw data that comes from an instrument needs to be converted into information and then transformed into knowledge and then synthesized in order to produce understanding. And I think this is honestly the best way of putting it, right? Most people are, most scientific writers only care about presenting information that they see. Some go ahead and transform it into knowledge by connecting it to different papers, different concepts, different history. But most never turn that sort of knowledge and synthesize it into what does this mean? Because we see this, what does that mean in general or in the greater scheme, right? So then just to kind of like end the talk, I just wanted to just reiterate, right? In order to write papers that get cited and proposals that get funded, we really need to focus on becoming professional writers. Embrace and learn from the struggles that come with the profession, make the reader's job incredibly easy, and become a storyteller. And I think if you frame your mind like this when you're writing a grant or when you're writing a paper, it becomes a lot easier to create understanding. And that's all I have. So thank you.
Thank you, Carlos. We are going to hold off on questions until after Keela presents on NSF, and then we'll be answering questions for both fellowships. Keela, are you ready?
Yes, that was great, Carlos. Like really, really good. That last section was super great. And I want everyone to keep that in mind as I go over the part that I'll be discussing for NSF, because yes, it is truly all about being able to tell a story. And he pretty much just summed that all up. So I'm about to share my screen in a second, and I'll be going over just some advice for the NSF GRFP. Can everyone see can you all see my screen?
Yes.
So just a little introduction. OMG, I'll try to make this quick. Oh my God. I'm gonna move really quickly because my computer is about to die and I thought it was charging. Okay, sorry about that. My computer is charging now. I'm in a better spot. But yes, my name's Keela. I am a third year now in the chemistry department, and I work in Kim Prather's lab. My research is on studying the atmosphere in general. I don't want to take too much time on that. So yes, at the beginning of this presentation, I really just have a lot of like, what can I say? Like the formality of the NSF GISP. A lot of this stuff you can find online. And so it really isn't that necessary for me to go too into detail on those things here, because you, like I said, you can find them online if you literally just Google. But just to go over a little bit of these things, right? To be eligible, you need to be a US citizen. You can be in your senior year of undergrad or your first or second year of grad school. One thing I do want to point out about this, because I'm not going to read every single thing from every slide, and I do just want to shout out Emily Zhu and Baki. They are two people in the math department who I created this presentation with, but they were not free today to present with me. So I'm going to be going over it all by myself, and I just want to kind of run through some of the slides that they would have did a little quickly. But one thing I will say is that if you are a first year graduate student right now, and you feel as though you don't necessarily have a topic that you are like 100% confident in submitting, then just wait till next year. Because I applied in my second year and I felt much more prepared. But I also had applied to a fellowship my first year just to kind of get that experience. So for those of y'all who are in your first year, I do still encourage you to maybe at least try to write out an application, write out a proposal. But if you don't feel 100% confident because you only did one year in grad, I would say to just postpone that until next year. Next, a little bit about the stipend. So it's $34,000 for 3 years and just in a 5 years. So you're able to like put a year on reserve if you decide that you want to, let's say, I don't know, take a gap year from school, or you have other funding that you want to use first before you use your NSF funding, you can kind of put it on hold for a little bit. Once you receive the NSF GRFP, you also have access now to some professional development opportunities known as GRIP and GROW. And these are just internships and funding that you can get to better support you and to get more opportunities while being a graduate student, because most people don't necessarily get those chances to go to like other locations and do research and whatnot. So as far as the actual application goes, you have a research statement, a personal statement, reference letters, and then the online application in which you have to fill out like your personal information, your education history, your work experience, etc. One thing I do want to point out is that NSF is super, super, super picky about formatting. So you want to make sure that you read the solicitation, I would say 3 times. One time before you start preparing your application, one time while you're in the middle of preparing your application, and then just one more time when you finish to make sure before you submit that everything is accordingly, because they will literally like reject your application based on one small thing. You can use Microsoft Word. As a UCSD student, we get that for free. So that's not too big of an issue, I believe. And, oops, sorry. So here is just kind of like a recommended procedure, I would say. We're already in the month of October, and most NSF or all NSF applications are due between, I just looked at the dates, I want to say it's between October 22nd and October 26th-ish. It's around that time, depending on your discipline and your field of study, you will apply on a certain day or submit your application on a certain day. With that being said, your recommendation letter writers do not have to submit their letter on the same day that your application is due. So that also gives you a chance to like follow up with them, send them the application that you submitted in whole so that they're able to take that next week, brush up, and then submit your recommendation letter. So I would just say, of course, start early. You want to make sure that you have time to do everything, get edits. Again, read the entire solicitation, choose your letter writers. This is super duper important because you want people that can say something good about you, and they take that into account. I would say that's probably one of the reasons that I actually got the NSF GRFP. You want to devise a project. Fill out the online application. I would say do that immediately. Like, even if you don't know for sure if you're going to apply, to just fill out the online portion of it, because it is a bit tedious, right? To sit there and fill out all your personal information, fill out awards you've received, and etc. And then you want to write and revise your statements. Next, I already kind of talked about this a little bit. You want to read the solicitation a few times. And you see, I can't remember who put this on here, but Vaki or Emily, like really, really, really want to make sure that you all go through and follow the nitpickiness of NSF. Also, a good thing I just want to point out is that when I was writing mine, a lot of people post their applications online after they submitted and received. And I have my application. If any of you all want to read it, I'm more than welcome to give that to you to read. I'll probably have to block out some sections. And then also, just as a plug, I'm also free to help you all maybe do like a last draft in terms of like the writing portion of it, not necessarily the science, because I'm a chemist and I don't know much beyond my field of study. Next, choosing your letter writers. This is just a little tip for that. Make sure you provide at least 1 month's notice. So if you haven't already and you plan on applying for NSF, I would say send that email like right now. Let them know, send them your CV, send them your resume. Maybe even something I did was when I didn't have my application ready, I sent like a paragraph summary of what I would be writing about, just so they had like some type of idea. Most of my recommendation letter writers, I worked with all of them already, so they had a lot to say about me. And something I want to plug that Carlos also mentioned, so with NSF, you can submit up to 5 recommendation letter writers. I think you only need 2. And you can put up to 4 or 5 on there. I strongly encourage you all to have at least 4. And I say that just because in my case, for example, I had 4 letter writers. One of my letter writers, a hurricane came through the city. His power went out. He wasn't able to submit. Another one of my letter writers kind of had some of this, a similar issue happen where the technology went out. He wasn't able to submit, and they both emailed NSF and they would not take those recommendation letters from my writers. So I ended up only getting 2 submitted, but you know, thank God that I have 4 people even lined up to submit a letter for me. So I would say that also if you're first year and you feel like you don't have 4 people to write a letter for you in this moment, to maybe, you know, take this next year, make those connections so that when you apply in your second year, you actually have 4 to 5 people who you can put down as a reputable source to vouch for you and your abilities. Devising a project, this is like the super duper most important part, I would say, because unlike Ford, I can't really say unlike Ford, but they do take into account your research a lot with NSF. That's their whole thing, right? Increasing diversity in the field, yes, but also getting people who are going to contribute and be future leaders in the field of science. And they want you to be heavy in terms of going into academia. You don't have to go into academia after getting NSF. I'm not interested in academia, but they kind of want to see that that's something that you are considering in terms of like taking that next step. So seek help from your advisor in terms of a project. A lot of people get really lucky when you come in, your advisor already has a project plan that they can give you to write about. But if not, spend time, read a lot, like a lot. I can't even emphasize how much you're gonna have to read. And then also just really be specific, because your research proposal is super short. I think it's 2 pages. And I go a little bit into that at the end, but you want to make sure that it's something realistic, right? You get funding for 3 years. They want to make sure that whatever project you are proposing to them, that you're actually able to do that within 3 years. So it's not like you have to go above and beyond and tell them that you're going to do the impossible, but they want to know that you have what you need and the mindset really that you need to be able to take on a project and receive that funding from them. I went over this already with filling out the online application. Like I said, kind of do that first because it does take a little bit of time. It's something that I ended up doing like soon as I created my NSF account on like Fastlane or research.gov or whatever. That was one of the first things I did. I talked about formatting. Again, they're really nitpicky about it. And make sure that you take time to see if your files will upload before it's actually time to submit, because that's also something that a lot of people ended up having trouble with, is submitting their PDFs. And the phone lines are super duper busy, like the last week of application. So they do answer the phone if you have a question or a problem, but I would just say be proactive about that in terms of trying to submit as early as possible. I do believe applications are due at 5 p.m. EST. So for us over here on the West Coast, that means you need to have your application submitted by 2 p.m. of whatever day that it's due. Write and revise your statements. This takes a bulk of your time, I would say. And so I go a little bit more into depth in both your personal statement and research statement at the end of this. Again, I would say, think about the things that Carlos said when it comes to this in writing, because writing is just super duper important, right? They don't just want to see that you can devise a research project, but they also want to see that you can write. So both statements must address intellectual merit and broader impacts. I go over that a little bit more later. You want to read as many successful applications in your field of study if possible. Read application reviews. If there's someone who's in your field who has NSF, see if you can find that and find their application. And then seek feedback from as many people as possible. I actually got my lab. I took over a group meeting one day just to have my lab review my application and give me feedback. And that was really, really helpful sometimes, because if you just send your paper to someone and they send you the edits, I would say at least take out the time to sit down with one senior grad student, postdoc, research scientist, or your PI, if they're free to do that, and give you that verbal feedback, because with writing, that's super important. And then also writing this will help you down the line when it comes time to write your first paper. Something to remember in terms of your entire application is that the NSF funds people, not projects. They're really heavy on that. That's their thing to say. And so even though I stress research really heavily, they want to see what's your value, what's your contribution? How can you make this research pop? The research pops on its own, but why do we want you to do this research? And so next I'll go over the personal statement and then the statement, questions you should ask yourself and things to think about when you start writing these. This is the personal, because it's your chance that act term is, who am I, right? They want to know
Hold on, Keela.
who they're reading about, who they're about to award this to.
Keila, can you turn off your video? You're getting a little choppy, so that might help.
Okay.
All right. Sorry. Okay, you can
Is
go
that
ahead.
right?
Yeah, I think that's good.
Let me know, yeah, because if so, then I can just connect to my hotspot. But yeah, so some questions you want to ask yourself is, who am I? What have I done? So in terms of your undergrad experiences, professional experiences, for those of you all who may have had a job or career opportunity already, what am I doing now? So what research are you doing now? What outreach are you doing now? Anything that's relevant. What is my role as a scientist? So, we don't just do research as grad students. Well, some of us don't just do research as grad students. So they want to know, what else are you partaking in? And this is a lot heavy. This is really heavily for your broader impacts, right? Because they want to know that you're not just in the lab doing science, but that you're taking the science, or you're taking your role as a scientist out into the world, so that you're mentoring people, you're doing outreach with younger students, you're volunteering in your community. You don't need to be doing all of these things, but they do want to see that you're active and not just in the lab. And then what do I plan to do, right? So what's your future research? That can be your grad school research. That can be what you plan to do after, and then your career goals, and etc. And remember, this is a story, not a report. So again, I just have to keep plugging Carlos's presentation because it was super good. And you just want to make sure that you are telling them about yourself and selling yourself in a really good and well-written manner. Some more advice on that is to organize your statement into subsections and think of ways to emphasize what's important. So personally, I really took a lot. I took advantage of being able to italicize and bold certain things. And as you can see on this slide, we did that just to make those things stand out to you. So you want to mention relevant awards, honors, and presentations. I think for personally, those were things that I italicized. And then my skills, I bolded them within my personal statement. Remember that your audience is likely not an expert in your subfield. With NSF, you do get that, I would say, the pleasure of, for the most part, they will be kind of close to your field. I think NSF they attempt to get your reviewers to be near what you're doing, just so that they can understand and make sure that it's like a feasible and reasonable project to take on in the next 3 years. When it comes to your research statement, I think it's about 2 pages. Don't worry about the length at the beginning, because as you get edits and as you talk to more people, it's going to get chopped down a lot. But still, some questions to ask yourself is, how is my research relevant to my research community? Why is my project new and interesting and exciting? What has already been done in your subfield to address your problem? And why are you the right person to solve this problem? And that's kind of also going back to what I said in terms of something that I strongly advise is that you kind of tie your personal statement and your research statement together. So if I can go back just a little, when it comes to asking yourself, what am I doing now? What is my role as a scientist? In your personal statement, you kind of want to bring some of those things into your research statement because they still want to see, okay, how are you going to take this research and take the skills that you're learning and use it in the real world? Because, the lab is small. We are all working on problems that are not necessarily minute, but that fit into the big, grand scheme of things. In terms of broader impacts, you want to know, what are the societal impacts of your research? How will you share your knowledge with others? And will you mentor others or engage with the community? And I wish Emily or Vaki were here, because they're in the math department, and that's very different, right? For those of you all who are in, let's say, science or engineering, where a lot of the things that we research are applications that are in real time that can be used to solve problems. Some of you all may be doing research or in a field where you don't necessarily feel that way. And something that I found when I was looking at other students' applications is that they would talk about, let's say, creating a blog so that they could share the things that they learned about grad school with new grad students, or having a social media page that you can dedicate to sharing your experience as a grad student with incoming grad students, or just other people within the scientific community and the regular community, the non-scientists, and how can you get non-scientists to engage with you and what you're doing. A little bit more advice is, be concise and thorough, provide what is necessary and nothing more, organize your statement into subsections. This helped me a lot when it came to writing, because then you can say, okay, well, my background is for me, that was the most important because the plan or the research that I proposed was just innovating and adding, combining two techniques that already existed. So I really wanted to use most of my research statement to talk about what had already been done and then just tie that together. Some people are doing something totally new, and so your background may not be as long, and then you can give more time to your problem statement in your research plan. You do need to specifically highlight your intellectual merit and your broader impacts. So intellectual merit was actually my background in my personal statement, and then broader impacts was a section that I put by itself at the bottom of my research statement. When it comes to that, still you want to make sure that you're straight and to the point. Again, like I said at the beginning, it does not have to be elaborate. Some people think, like, oh, my research, I don't know, so I don't want to apply for NSF because I'm not doing some grandiose idea, and they don't care about that. They really just want to know that you care about what you're doing and you care about how you can contribute to the community as a whole. I would like heavily emphasize to include either one figure or one equation. I literally don't know anyone who's received the NSF that had no figures or no equations. So figure out something to be able to put in there so you can illustrate what you're doing or what's already been done, or equations that can help you get to where you want to go. Get feedback and revise repeatedly. I would say that 10 times if I could. My lab was pretty big. I literally got like 5 different people in my lab. Consecutively, I got feedback from one person, I did the edits, sent it to the next person, got feedback, and do what works for you, right? You don't have to do that method, figure out what works for you. I kind of just didn't want to put the burden of going back and forth with one person who was probably busy and wouldn't be able to meet with me that much to work with me. So, figure out who in your lab you can trust, who you feel comfortable with. And for most people, that should be your PI. But if your PI is busy like mine, then, use your resources. And that's something else that I don't think I said that is important when it comes to this is showing NSF in your research statement, in your personal statement, that you take advantage of the opportunities and resources around you. So for example, my project is a collaboration. So I pointed that out, right? That it won't just be me. I'll actually be able to, go to another university, work with people at another university, and take what I know and what they have and the access that they have to better my project and get to the final result. So any, collaborations you can talk about, any equipment or instruments that are like one of a kind or, super, I don't know, just really good that you're going to be using in your project. Talk about that, right? And I guess one thing I should say too, to kind of wrap this up is that you don't have to do the project that you submit to NSF. That's not really what they care about. They just want to see that you can clearly think about a problem with the solution, and then use that throughout your grad school career. You don't necessarily need to do that project. I'm doing my project that I proposed, but I know several people who received NSF that are not doing what they proposed. So I wouldn't say stress too much about having an idea that you're going to follow through with, but do make sure that you have an idea that is relevant and can actually be solved if you were to do it. And that is all. Are there any questions?
Thank you so much, Keila.
I know it's like choppy.
Can you all join me in doing the clap emoji for Keila and Carlos? Thanks so much. And we can go ahead and take questions now if you have them. Ayush?
Hey, I wanted to ask, how hard, how stiff is that policy for US citizenship or resident?
It's very strict. I don't know how you report it. Honestly, I don't remember that part of the application, but I think they're very strict on being a US citizen.
Also applies for the Ford, but I also don't remember submitting any documentation that said otherwise. So,
okay, thanks a lot.
Well, if no one else has any questions, I'm going to ask, do you know how the NSF fellowship combines with other fellowships? Or like, can you combine it with other fellowships? Is there like a maximum amount of funding you can have each year?
Yeah, so I don't think you're not allowed to combine fellowships. Like at the moment, I have several, but I'm only allowed to use one at a time. And so then by default, some of them end up dropping out. And so since I got NSF at the end of my second year and I'm now a third year, by default, I'll use NSF for my third, fourth, and fifth year. And if I need funding for a sixth year, then that will come from a fellowship that I had when I first started. But another fellowship that I had, they emailed me and was like, oh, you got NSF, so you're not going to get this money anymore. And I think
oh,
departments have a cap. Oh, that was it.
Sorry, no, I will say, because actually I did win the NSF and I didn't find out about this until later, but if you win both the NSF and the Ford, you can take it one year, then defer it, take the other one that year, then defer it, then take the other one again, and keep deferring until you use up both of them.
Okay, cool, thanks.
Is it okay if I just jump in here? So I feel like this is fairly award specific. So Keila and Carlos, if you're not aware, Kayla is a Sloan Fellow, and Sloan is meant to be on top of other awards because it's not like a full stipend amount every year. You know, it's just sort of like that extra little topping. So that's an example of when you could have, say, NSF or Ford and Sloan, but it's really it's really award specific. The award letter or notification or whatever you receive should outline all of those specifics. Right. Yeah, I think usually if you check sort of like the FAQs on most of these fellowships, they very clearly state that you cannot have, or these cannot be combined with other awards, right? But I think it's also like a distinction between the types of like grants and fellowships, right? These are fellowships as opposed to like the Sloan Award, right? Which will be on top of any of these other ones.
I also want to plug, there's a, I know you are not in Sloan. I'm not sure if it was a Sloan event or a Grad Talk, but last year I attended a writing workshop with Sinai and Shayna, and it was really helpful. Like it was definitely very useful. So I would look out for that this quarter for those of y'all that may not be applying now, but you intend to apply in the future.
I have a question about including figures or equations. So in the research proposals, I mean, for both fellowships, the length limit is pretty short. So how do you decide when it's more important to include an equation or a figure versus explaining something in a section?
I do have so the Ford is very different from the NSF, because the Ford, what actually matters most is this like personal statement or whatever, as opposed to the NSF, which likes to reward like really research intensive kind of like people that apply, applicants. The Ford, I did not put any figures on my Ford application when I won it. But for the NSF, when I did win that, I included 2 figures, because you have to show that you have some, that the sort of like experimental plan that you are proposing has some merit to it. It already has some preliminary data. It can't be all hypothetical. This is more for second years maybe, but I believe for first years, this is probably also certainly the case for those that win.
Yeah, Emily and Vaki, who are math students, both said like they definitely had at least one equation. I'm not sure how many they had, but they both said they definitely had at least one. being math students, I would say if you're maybe like in physics or engineering and you can't devise a figure based on your research plan to then figure out some equation that you can just tie into it. Personally, with chemistry, I had a experimental setup. So I had no data and I had a slight idea that it would work, and it's working now, thank God. But yeah, I just put a schematic of my experimental or instrumental design because I'm developing an instrument, and that was sufficient. And most of the applications that I reviewed that are like posted on the web kind of did the same thing in terms of equation or like experimental setup.
Okay, thank you.
We'll say writing these type of fellowships is an art in itself because, like you mentioned, you have two pages to write this stuff, which is actually insane if you take a look at maybe like the F-31s or more like research intensive applications that give you like 12 pages to completely write about your research, single space. This has to be 2 pages, double spaced, 12-point font. It's incredibly difficult to condense your thoughts into something this tiny, which is, yeah.
Yeah, something I didn't say, but I believe is in the slides, and I think Sanaya or Shayna has the slides to share, is that for NSF, you also need to include references. And like that's important. I'm not sure that they like double check your references or anything like that, but definitely include them. And so that was hard for me to like put a figure and for references. So I literally shorthanded the references as much as possible. Like it's like first author, and I think the year. I like the first author, the journal title really shortened, like the abbreviation for it, and then the year, just so I could fit like 10 or 11 references in my paper. So they're like at the bottom, the very, very bottom, because you cannot exceed like the margins or anything when you upload your PDFs of it. So with that, I would say do a lot of reading and then pick very specific papers and very specific things to include, which when you go through edits with like senior research students or postdocs, they should be able to help you like say like, oh yeah, this isn't relevant.
Awesome. Thank you so much again, Carlos and Keila. That was an amazing presentation, so much information. And you all have their emails. They put them in the chat in case you missed it. But I can also share via email the link to the recording and their contact information. Thank you everybody for coming. Have a great weekend. Bye.